UDP stands for User Datagram Protocol. Okay. So now let's look into. So first of all, what are the services provided? Services. What is happening? Services provided. What are the services provided by TCP? If you remember, the services provided by UDP. So first one is process to process communication. Okay, it doesn't matter. So whether the protocol is TCP or the protocol is UDP. So that has to be the first and foremost important. So service to be provided by any transport layer protocol. So first one is process to process communication. Okay, the first services to be provided is process to process communication. Then the second one, so in UDP is multiplexing, demultiplexing. That also has to be carried out by TCP. Okay, so because in order to achieve process to process communication, we need demultiplexing. So that's why multiplexing or demultiplexing is another important service to be provided by TCP. Okay, and what we discussed in the last class, so UDP is packet oriented, whereas TCP is stream or byte oriented. Okay, so that's why it provides the service of stream orientation. Stream oriented. TCP is stream oriented, or we say it is a byte oriented, whereas my UDP is called as a packet oriented. That we discussed in the last class. Okay, so then coming ahead, so we have already talked about, so TCP is connection oriented, UDP is connectionless. So it provides a connection oriented service. Connection oriented service. Okay, TCP provide connection oriented service, and due to this connection oriented service, we could able to achieve reliability. So that's why another important service provided or function provided by this particular TCP, that is reliability. Okay, so reliability is achieved due to its connection orientation in nature. Okay, but remember this thing. So just making a transport layer protocol connection oriented, I cannot able to provide reliability, but that is the first step. We can say that is the first step towards reliability. So but to achieve reliability along with this connection orientation, we need certain extra features. Certain extra features need to be supported by TCP so as to achieve reliability along with the connection orientedness. So first one is flow control. These are very, very important points. Everybody please focus very carefully. So first point, to achieve reliability along with connection oriented, so that is the flow control. So next to flow control is the congestion control. Congestion control. Next to congestion control is the error control. These three things needs to be supported by TCP so as to achieve reliability. Let's discuss one by one. What is a flow control, what is a congestion control, and what is a error control? Let's look into that very carefully. Now, just a minute. Okay. Now, if I look into this diagram, because I already always try to use this diagram, which is the backbone of this computer network in my sense. So this is the source, and this is the destination. This is my destination, and they are connected normally via routers. So this is the picture I have depicted, that's why. Okay, so now if I look into this picture, what I mean to say is flow control. So let's say, for example, the sender, the capability of the sender to transmit data into the network is 100 Mbps. Let's try to understand very carefully. Okay, so sender can go and transmit data into the network so by using 100 Mbps link. Okay, but as far as the receiver is concerned, its capability to receive data at a particular point of time, so there is 50 Mbps. That means a receiver can process 50 MB of data per second, whereas sender can send 100 MB of data per second. If the sender is going to send data continuously, okay, send data continuously to the destination, can anybody think of what is the problem going to arise? Can anybody just think of? Sender is continuously sending at the 100 Mbps speed. Receiver is only capable of processing data at 50 Mbps per second. So at that point of time, what kind of problem might arise at the receiver end? Can anybody think of? What? The receiver capability. If the sender could able to cut down its speed to 50 Mbps, okay, instead of 100 Mbps, though it has the capability of sending so data at 100 Mbps, but as the receiver is not capable of receiving the data at 100 Mbps, so what the sender will do? Sender will cut down its speed to 50 Mbps. If the sender is going to cut down its speed to 50 Mbps, so then no problem is going to arise. And that is what is nothing but the flow control. Think of flow control. Flow control is nothing but controlling sender as per the capability of the receiver. Capability of the receiver. Okay. So controlling the sender as per the capability of the receiver, if I could able to do so, so that kind of mechanism is basically referred as a flow control. Okay. And in doing flow control, what we achieve? We are achieving reliability. We are so able to cope up with the packet loss, and that is nothing but the reliability, na? So that's why, so one of the parameter, so to achieve reliability is flow control. And what the flow control says, so control the receiver, sorry, control the sender end, so as per the capability of the receiver. That's what the flow control talks about. Okay, so now, so let's look into the next part of it, congestion control. I've already cut down the speed of sender to 50 Mbps. Receiver speed is 50 Mbps. But let's say, so this router speed is 20 Mbps. We have not discussed about the router. We have only talked about in flow control. What we talked about? Only sender and receiver. Only sender and receiver. As far as flow control is concerned, we are only so concerned about the sender receiver. We are not concerned about any of the intermediate node as far as the flow control is concerned. But if I say, so when the packet communication is going to happen, packet communication has to happen through the intermediate nodes. If it is going to happen through the intermediate nodes and my intermediate node capability is less than the capability of the receiver, in that is a chance my packet loss can happen because my intermediate node, that is the router, is having a capability less than the receiving capability. So that's why, so still there is a, even if I apply the flow control, still there is a chance of packet loss. How to handle it? So that is called as a flow control. That means flow control talks about controlling the network. Controlling, this is the network part, na? This part is the network part. This is the sender part, this is the receiver part, this part is the network part. So controlling the network capability. I mean controlling the network. That means as per the capability of the network, we have to control the send and receive. Okay, so controlling the network. So that means if that is possible, so if I can slow down my sending to 20 Mbps now, there will be no problem as far as communication is concerned. That is what is called congestion control. That means congestion control, applying congestion control on top of flow control, we can able to achieve reliability. That means flow control talks about the sender and receiver, both end users. So harmonizing or synchronizing the sender and receiver. So but congestion control talks about harmonizing the network and the sender and receiver with respect to each other. So that's why both applying flow control plus congestion control, packet is traveling. I have make it 20 Mbps. Okay, the sender is sending 20 Mbps. So network capability is 20 Mbps. Receiver capability is more than 20 Mbps. So in normal circumstances, so there is no packet loss. But so whenever we are communicating the packet, there is every chance. So let's say packet I send from source to destination. Now it has come from source to router. So while it is going to send from router to destination, the packet may be lost. The packet may be lost. You can't guarantee that. So during the transit in the network, in the OR, so the packet may be lost. Okay, or it may happen. So packet may be corrupted. I mean, two packets may be collided with each other. So it got corrupted. Once the packet got corrupted, so there is no meaning in forwarding the packet. That is a kind of packet loss. Okay, so packet loss can happen because of several reasons. So packet may loss naturally, packet may be corrupted, or it may happen the same packet might be going to receive multiple times. Okay, so you'll able to know about it later and exactly why it is. Okay, but for the time being you understood, even if I have applied the flow control, even if I have applied the congestion control, still I cannot give the guarantee that my packet is going to receive at the receiver end correctly. Okay, so that's why we need another control. So that is called as the error control. So error control is, so to talk about, so three things: packet loss. To cope up with packet loss, packet may be lost even if I have applied the flow control, congestion control to synchronize the packet communication, to harmonize the packet communication in the network, but still I cannot so ensure my packet can loss. Okay, so there is every chance, always in reality, whenever transmission is happening, packet may be lost. The second point, so packet may be corrupted. Packet corruption may occur. Two packets may be collided with each other. So, and the packet will got corrupted. So out of the collision. So that's why once the packet is collided, so and it is just has no meaning. So packet is modified. So we have to so discard that packet. So then packet may be duplicated. Packet may be a duplicate packet. Okay, that means the same packet is going to receive multiple times because of so techniques that is applied in TCP. We'll talk about later on. For the time being, you only remember this concept. Okay, so that's why what you understood, even if I have applied flow control, even if I have applied congestion control, still I cannot ensure reliability. So that's why on top of it, what I have to do, I have to apply one more control that is called as the error control. What error control talks about? So error control talks about if there is a packet loss, what to do, if there is a packet corruption, what to do, if there is a packet duplication, how to so deal with these so three scenarios to ensure reliability. That is what is so functionality or talks about the network. So then error control talks about handling these three so different so scenarios what might occur during the transit of a packet. Okay, so if I apply all these three, so flow control plus congestion control plus error control, then only I can ensure reliability, otherwise not. So this is what TCP is going to do to so achieve reliability. So that's why TCP is very complex in nature. If I look into the UDP protocol is very simple in nature. That's why you say na, so the communication when happens using UDP, so it is very faster because it is very simple, and also it is having less overhead. Less overhead means so amount of extra information is going to go inside the packet. So for transmitting a packet using UDP is very less. That is only 8 bytes. So that's why so UDP is very simple protocol, and also it does not deal with reliability. The complexity, there are a lot of complexity is going to come whenever we are going to deal with the so reliability, so which consumes a lot of time. So that's why so in order to achieve reliability, we have to so a lot of time has to be invested to so go and make the communication as far as the packet communication is concerned. So that's why TCP is slow in nature, whereas it is reliable. UDP is fast in nature, where it is unreliable. This is what the basic of TCP